Good morning, physical geographers. Welcome to Geography 112. So just a quick note, I know we did a little bit of a discussion, like introduction on the welcome video. To organize things as far as the way the geography department's set up, the first half of this book really is devoted to 112, which essentially we talk about climate and weather. The Geography 111 class, which is the second half of this book after chapter 8 to the end, is really Geography 111, which is landforms. Just a quick note. Okay, so I decided for the online class, although there's a lot of good online material, to put together for each chapter to kind of make the reading more digestible, easier, put together some presentations that accompany the reading for each chapter to kind of boil down quickly what the topics are in terms of the content for each chapter. So the first chapter we have Introduction to Earth. So we have geography and science. As you may know, I also teach world regional geography, human geography, and geographic information systems. My 8 to 5 job, I'm an adjunct at Front Range. My 8 to 5 job, I'm actually a senior IT architect for Department of Interior. So I do a lot with geographic information systems, geography, and the science of it. So really what we're talking about is studying the world geographically. Earth, basically having maps associated with it. The process of science, numbers and measurement systems, which we'll go into detail in some of the labs in terms of great circles and how to identify distances and the mathematical ties to that. Environmental spheres and Earth systems, Earth's environmental spheres, and corresponding Earth systems. Okay, so we have multiple systems. We have Earth and the solar system. The solar system size and shape of Earth, which we'll get into as far as being a plate spheroid, slightly flattened at the poles. The geographic grid, we have latitude, which runs east to west, measures north to south. Longitude, the converse, so it runs north to south, measures east to west. We'll talk about the reference meridians for that. Locating points on geographic grid. Okay. And then we'll get in a lot of Earth-Sun relationship in the seasons. So, till the Earth's axis, revolution around the sun, all that good stuff. So, Earth movements, annual march of the seasons. So, those two factors I mentioned will affect that, seasonal transitions and significance of seasonal patterns. We talked about in Geography 105, World Regional Geography, a lot of different patterns based on where land, weather, and climate, which ties together Geography 111 and 112, how different patterns happen throughout the world, both on seasonality and basically landforms. Telling time, the ideal international dateline, daylight savings time, why do we need that? Standard time. Okay, so description of the Earth. Here we talked about this in my introduction welcome video. We talked about really the different parts in physical geography versus human. So in a nutshell, humans more cultural, all the aspects that affect people. And physical, really, the bottom part of this is most likely what we're talking about in this class, the landforms, rocks, and minerals. Some of the water actually is in Geography 111. And then the bottom ones, plants, animals, soil, weather, and climate, it's really more in this class. Geography 112. So spatial science is both physical and social, which is really what we're showing on this slide. Scientific methods, we have approaches where we study the physical environment through physical geography. Data collection and eliminating explanations. We do have a data collection GPS for GIS class that Rick Kohler teaches here at Westminster. We have sections at some of the other campuses. Theories developing through review, through a method, review, and uncertainty. So really we're suggesting, once again, the scientific method, observing phenomena, putting together a hypothesis, testing it, and then predicting outcomes, and then drawing conclusions, whether it meets our expected outcome or not. Measurement systems. So we've all heard of English and metric. Pretty straightforward. Lithosphere, atmosphere, hydrosphere, biosphere. I talked about this in the welcome slides. This is really what this class is all about. Lithosphere, rocks and mineral matter. Atmosphere, mixture of gases, which we'll break down. Hydrosphere, water in all its forms. Gaseous state, and then solid state, and then liquid state, all of that. Biosphere, where living organisms exist. So we're talking about plants and animals. Both of those, which basically make up organic matter, the basis of organic chemistry. Okay, so Earth systems. We talked about Earth systems, solar systems. So we have closed systems, isolated from outside influence, open systems, where energy, so forth, can exchange. So that's kind of more of our interface to the galaxy and our different spheres. Interconnected systems of changing one and the other, equilibrium. Inputs and outputs and balance. We see a lot of that in physics. We won't cover that so much in this class. And then feedback loops. Essentially, feedbacks reinforcing positive and negative change. Okay. Glacier systems is open, internet-connected systems. So a good example of glacier systems, the Great Lakes we have. Many large cities are touched or impacted by that. A lot of transportation that we use. So essentially glaciation we also see in Colorado. Solar system is an open system. We talked about open and closed. So what are some aspects of that? One is energy can be transferred. A very large basis of climate change we talk about. Solar system, so we talk about it's not the exact mathematical center, is not necessarily the sun. It's close though. It has a lot of gravitational pull for sure. 8 planets revolving in elliptical orbits, and then we talk about some gas giants, planets, and Earth is basically the third one from the sun. So notably, geography classes are in the science department at Front Range Community College. So there's a lot of synergy and good overlap. Earth size, we'll discuss that. Maximum relief, where the highest mountains, lowest mountains at sea level, subterraneous, essentially terrain, which is at the bottom of the ocean. And then we'll talk about the Earth's shape. We have some labs that'll fit that nicely. Latitude, longitude, we discussed earlier. Longitude lines converge at the poles, North and South Pole. And then the parallels are also lines of latitude are run along the same distance from the equator, which is in the center. Geographic grid. So these are essentially what we derive our projections from. Basically take some kind of form, put it on the Earth. We have tangent lines, either tangent points or lines. Great circles. The biggest circle you could draw, so you take the widest part of the Earth, and basically you can have great circle routes that follow where that widest part occurs. Good example on the top graphics. Okay, so here's basically delineation of lines of latitude, offset north and south. North of the equator has degrees north, south of the equator has degrees south. Different parallels help us organize essentially where the sun reaches in terms of different seasons and tilt of the Earth. We have different zones that help with that. And they also help define the polar regions. Geographic grid we talked about earlier. Rotation of the Earth, so it rotates in one different area, which causes basically certain types of things such as wind currents and water currents. So for instance, if we see a tornado occurring or a cyclone occurring, there's a certain direction that happens in the northern hemisphere. That's all reversed. Same with water. So a really good example of water is just flushing a toilet. Essentially could see the water go down a certain way. Then we get into Earth's revolution, so that's the Earth going around the sun, elliptical orbit, different distances, aphelion and perihelion are different distances, and then we really kind of go into what drives seasonality. Polarity of the Earth's axis always points towards Polaris, so essentially that's basically part of what keeps our Earth rotating around an axis of 23.5 degrees. Okay, and that's part of why we have on the previous slides, why we have the different tropics at 23.5 degrees. That also helps us, the revolution and the tilt of the Earth's axis helps us have different seasons. The Earth-Sun relationship drives the seasons. Declination of the sun is basically latitude receiving vertical rays of the sun. Solar altitude, sun's height over the horizon. So how high is it coming up in terms of when the day starts in North America and specifically the United States. We see that in Cadillac Mountain in Maine. And then length of the day, so that changes. Length of the day gets much longer in summer, and then we see it shorten in the winter. So that's what drives all of that. We have June solstice and summer solstice. We also have what are called equinoxes, which is the same time, 12 hours of light, 12 hours a day. So we see that all driven based on where the Earth is presently at as far as revolving around the sun in a year's time. So it basically migrates, the vertical rays migrate between the tropics. So sometimes based on the tilt of the Earth's axis, sometimes we see more sunlight in the southern hemisphere, and sometimes we see more in the northern, which basically depends on where the Earth is at with respect to the sun throughout the year. This also impacts day length. Okay, so a lot of significance in seasonal patterns. We usually see storms, hurricanes, cyclones, typhoons, all that kind of very severe weather, if you will, like we had last year and also in 2016. Last year we had a very bad hurricane season. We see a lot of that at certain times of the year, usually when energy's build up and it's warming up. Standard time zones, so typically we have 24 time zones, which are 15 degrees apart. The map at the top here shows that nicely. We have different geographies. A lot of times major cities are identified with each time zone, but we also have names for them, like Mountain Time for Colorado, Central Time for Iowa, Kansas, most of Texas, and so forth. We break that out throughout the year, and then we have basically where time starts on the international date line, which we see right in the center. We see pretty close to the center, which essentially goes through Greenwich, England. Telling time, so we use it to tell time. We also synchronize that with the atomic clock. You can look that up online, even find web services, use it to synchronize all kinds of things from anywhere from your watch to a computer to clocks that you might have set in your house and so forth. Okay, so that finishes up chapter 1. Looking forward to seeing you online and in the labs and going through the other content. I've got to have some nice content set up where you can kind of test your knowledge, working through some online examples, do a little bit of reading, take a little quiz, reinforce your knowledge, that kind of stuff. And with the quizzes also, you'll see online with that. If you have questions, please do not hesitate to contact me, email me, and you can also use my phone number, voicemail through phone.